is triangle basics. 4.1 and 4.2 are pretty basic stuff, not real meaty. That's why I can do the notes all in one day. There are two main ways to classify triangles, by their sides and by their angles. So you're either going to name it based on their sides or you're going to name them based on their angles. And that's what we're looking at today. So first, by their sides. Does anybody know what a scalene triangle is?
Isn't that one where one angle is...
But we're talking about the sides.
All the sides are different.
So what you're going to say, Diana? Yeah, all the sides are different lengths. Let's do this in a mathematical term. No congruent sides. No equal sides. How about isosceles? Diana, what do you think?
One, two of the same.
Right on. At least two congruent sides. An equilateral. The word lateral means you're referring to sides. Dom, what do you think?
All equal. They're all congruent.
Three congruent sides. Very good. Okay. So take just a minute to write down what kind these are. Hopefully this is what you got. Equilateral. What do the little dash marks mean again?
Equal.
Yes. Keep that in mind. Those three are equal. None of them are equal, and these two are equal. So equilateral, scalene, and isosceles. All righty? Turn the page. So the first page was about sides. The second page, we can also name triangles by their angles. So they're somewhat similar, but you're talking about angles here. So acute. Does anybody remember what acute is? Acute angle. Morgan. That's right. So smaller than 90 degrees, right? Smaller than 90 degrees. So an acute triangle always is going to have three acute angles. Because if you think about it, it's the only option. If there's a right angle, then there's only going to be two acute angles, right? If there's an obtuse angle, there's only going to be two acute angles. So an acute triangle has to have all three acute angles. All smaller than 90.
It's the small little cute angle.
Yeah, they're cute. Okay? All right, right. Right is a one, it just has one right angle in the triangle. I'm guessing this is stuff that you probably learned back in 5th grade.
We learned this.
Maybe 4th grade, maybe. Okay, but it gets a little better. Don't worry. Obtuse. What do you think an obtuse triangle is? Let me ask somebody else. Maddie. Yeah, you, Maddie. Oh, you're next to each other. Oh my gosh. Okay. Maxie.
That all the angles are more than 90 degrees.
Okay. They have to be more than 90, but there can really only be one angle that's more than 90 degrees. For the triangle angles to add up to 180. So one obtuse angle in it. Bigger than 90. Okay. Equiangular. On the other side we had equilateral. The word lateral refers to sides. Equiangular. What do you think, Sam?
Isn't it 45 different angles?
No, because 45 plus 45 plus 45 doesn't add up to 180. But I don't want to know really what the angle is. I just want to know what this means. What do you think this means, Leah? Yeah, three congruent angles. And there really is only one measure, but it's not 45 yet. Yes. Yeah. Okay. Draw a triangle that meets the given constraints. That means it's got to meet these requirements. It's got to be an isosceles and a right triangle. So isosceles, the two sides have to be equal, so this is maybe what I would draw. Yours might be slightly different. I would make sure it shows that it has a right angle, and I would show that these two are the same. Yours could be different, rotation or whatever, but something like that. Isosceles, right angle, triangle. Okay, how about an obtuse scalene? Obtuse means one bigger than 90, and scalene means what? All different sides. So something like this, perhaps. Okay? So this one is definitely bigger than 90. It's an obtuse angle, and my sides are not the same. Okay, acute equilateral. Okay, so they all have to be less than 90, and the sides have to be equal. So I would do something like this. And I would signify that the sides are equal with the little dash marks. Isosceles obtuse triangle. So I got to have one big angle, but two sides the same length. So something like that. This is my obtuse angle, and these are my two equal sides. Doable? Okay, it gets better. Ready? Turn it over. All right, now, types of angles. All right, so I want you to just kind of shade in these angles here, just like a little bit, so you know what we're talking about. So when they're inside the triangle, what do you think they're called? What's the math term we've used for inside? What'd you say? I heard it. Interior. Interior angles. Easy enough, yes? Okay. On the flip side of that, I want you to kind of shade this in, these angles, only these three here. So, Allie, what do you think those are called? Exterior. They're outside. Now I'm going to have you write a little bit to this one. Exterior angles are angles adjacent. Oh, what's that word adjacent mean again? Somebody knows. What'd you say, Julia? Not quite. Not quite. No. Oh, thank you. I was going to demonstrate. Next to each other. Next to. Angles adjacent to interior angles. And we usually only show one exterior angle. Oh, sorry, that's kind of a mess. At each vertex. And I'll show you what I mean in a minute. So, angles adjacent to interior angles, and we usually only show one exterior angle at each vertex. Now, you don't draw this, just watch. I'm going to explain what this means right here. If I were to extend this line, you don't need to draw this. If I were to extend that line, here's a vertex, yes? The corner of the triangle is the vertex. You don't demonstrate exterior angles by showing all of these. That's what that means. You really only just demonstrate one of the angles at each vertex that's outside. Make sense? Yes, no, maybe? Okay. All right, here's a theorem. You ready? I bet you can guess what this theorem is about. Triangle sum theorem. What do you think it's about? They all add up to 180. Okay, so here's the formal words. The sum of the measures of the angles, there's a lot of ofs in here, of a triangle is 180 degrees. Well, we're going to write the symbols as well. So say I have triangle ABC. I can then say that the measure of angle A plus the measure of angle B plus the measure of angle C is equal to 180. That's the symbol form. Okay, this bottom part is really like you were just doing on the Bart Simpson worksheet, so I'm just going to tell you 65 plus 50 plus whatever A is has to be 180. So I'm just going to tell you it's going to be 65 degrees. Next one is 75. It's really the same thing you were just doing. Now here, this one's just a little trickier. We need to know angle C. We kind of have to look at the picture and say, I have a triangle. I'm going to make this pink. Inside a triangle, I'm going to make this big one blue. See that? I have a triangle inside a triangle. These are both right angles, correct? This is a right angle, this is 50, therefore this must be how many, do you know? This must be 40. Oh. Now look at this. The big triangle and the small triangle both share angle A, don't they? So therefore C must be what? This is 90, this is 40, this is going to be 50 as well. It's the same thing. You see that? They share that same angle, that's 40. Okay, one more page. Okay, exterior angle theorem. So, here's another theorem. The measure of an exterior angle of a triangle is equal to the sum of the non-adjacent angles. When you're done writing, we're going to label this a little bit, and then I'll do the symbols. I want you to label this A, this B, this C, and this angle right here is going to be angle 1. This is your exterior angle. Okay? Now we'll talk about what they're meaning here. It's saying the measure of this exterior angle right here is equal to the sum, which means what? Sum needs to do what? Add of the non-adjacent angles. Okay, so here's my exterior angle. Which angle is adjacent to it? This one, right? See? So which two are the non-adjacent angles? These two. So they're saying if I add these two up, it's going to equal this angle. Isn't that nifty? Yes. Let's write it down in symbols. The measure of angle 1 is equal to, how do you think you would write that? In symbols. Yeah, is equal to the measure of angle A plus the measure of angle B. No, not quite. No. This is C right here. 1 and C do not have the same measure. They would add up to 180. But they don't have the same measure. Okay. So let's practice that a little bit. We need to know this angle measure. We just learned that these two angles would add up to equal the measure of angle 2. 60 plus 60 is equal to 120. So the measure of angle 2 is 120. In here, these are the two non-adjacent angles to angle 3. So 125 plus 30 equals 155. The measure of angle 3 is 155. And here, if you add this plus this, you get the measure of angle 4 is equal to 113. We should put degrees in there to be accurate. How is that for timing? Woohoo!